Okay, I'm going to be picking up here, doing some more videos here for the integration by parts. And let me get this started here. Get my microphone fixed. Okay, I think I left off doing number 20. So we are going to do number 21. Which was integral t cosine hyperbolic t dt. And again, we're going to ignore the numbers up here. So the only real challenge here is that we have a hyperbolic cosine function, which is a little bit different than what we've seen before. But we still have a t, and then we know the derivative of this involves hyperbolic sine, and antiderivative involves hyperbolic sine. So we know that to get better, a better integral and integration by parts, we'll go ahead and use the t as our u. So u is going to be t, dv is everything else we see up here, which is the hyperbolic cosine function, dt. The derivative of u is just dt. The antiderivative of cosine hyperbolic t is the hyperbolic sine t. And now this will be equal to ultraviolet, so this times this. So t hyperbolic sine t minus integral of just these two multiplied, v du, which is hyperbolic sine t dt. And the antiderivative of hyperbolic sine t is going to be hyperbolic cosine t, but not negative. So just go back and look at your formulas for the derivatives of hyperbolic trig functions. So this is just going to become minus cosine, minus because of this, minus cosine hyperbolic t plus a constant. And that's it. Okay, let's look at the next one. Oh, this was number 21. Okay, so the next one is 22. Okay, arctan 1 over x dx. So 22. Arctan, I'm going to put this 1 over x dx. All right, well, not real happy with this because I only have one factor here. So this is one of those ones where we don't have a lot of choices for u other than this itself, and it doesn't look like things are going to be nice, but let's just try it to see what happens. So I'm going to let my u be the arctangent of 1 over x, and then dv by default has to be the dx. And I'll do this one first. The antiderivative of here of dx, the antiderivative is just x. Now this derivative is a little involved, so let's think through this. Du is the derivative of arctangent of something is 1 over 1 plus that something squared, 1 over x. Square the whole thing, so that squares the 1 and the x on the bottom. So it just becomes 1 over x squared. But then times the derivative of what's in here. And the derivative of what's in here, remember this is like x to the negative 1. So the derivative of that is negative 1 over x squared. And then times dx. So this doesn't look very nice, but when we do our voodoo, things are actually going to be pretty good. So let's write out the formula. It's ultraviolet, so x times that, x arctan of 1 over x minus integral voodoo. So I'm just going to write all of this out, this times x. I'll put the x first. X times 1 over 1 plus 1 over x squared times negative 1 over x squared times dx. Now let me clean this up here. First of all, I'm going to put the x on top. I'm going to take the negative out here and bring it out, so it's going to be plus integral. The x is on top. On the bottom, Notice I have this, and then there's an x squared out here. I'm going to distribute the x squared through. So x squared times 1 is x squared. And then x squared times 1 over x squared, the x squareds cancel, and you just get plus 1 dx. And look how clean this integral looks. Now in the front, I still have x arctan 1 over x. But this integral I can do with the basic substitution. If I just let u be the denominator, the derivative of that, 2x dx, I have an x dx, so I'm only off by 2, so I have to scale this. And then at that point, or at this point, I can rewrite that integral. So this integral becomes, the x dx is 1/2 du, so this is going to be 1/2 integral du. And then the x dx is gone. I have a 1 over this, but that's u, so this is just 1 over u. And the antiderivative of this is natural log absolute value of u plus a constant. So u is this, I'll put that in here. So I'm ready to rewrite my answer. Had the original ultraviolet minus, oh actually it became a plus, so plus, and then this integral right here, we just said turns into 1/2 natural log absolute value of u, but u was x squared plus 1. Plus c. And that should do it. All right, let's look at number 23. Okay, for 23, integral cosine inverse x dx. Again, this is one of those ones where you only really have one choice for u. It's that inverse cosine, and that forces your dv to be dx, which means v is x, integrating, and then differentiating. So du -1 over square root 1 minus x squared. I'm just going to double check that. That should, dx, that should be our derivative. I shouldn't have to look this up, but I just want to make sure. Yeah. Okay, so that is our derivative of our cosine. So, I'm sorry, of cosine, yeah, cosine inverse. So, this ultraviolet, x, our cosine x, minus integral, and then voodoo, this times this. So I'm going to slide the x on top, up here, and then I'm going to put that -1 out front. The -1 is going to change it to a positive. I'll have the x, and then the denominator, square root 1 minus x squared dx. Again, this one I can do with the basic substitution, use 1 minus x squared. The derivative of that is -2x dx. Scale this, -1/2 du equals x dx. So I've got the x dx is this. This whole thing inside here is u. So this integral becomes -1/2 integral 1 over the square root of u du. And then this right here is -1/2 integral u to the -1/2 du. And then just do your power rule on this, add 1 and then 1 over that. And so you should get a -1/2 times 2u to the +1/2, and then plus a constant. But remember, u is this. So the 2's are going to cancel here, and we'll just get negative square root, because that's what that means, of u, which is 1 minus x squared. So this whole integral right here becomes this, and plus a c. So my answer should be, that plus is going to change to a minus because of this, minus square root 1 minus x squared plus c. All right, let's look at number 25. Oh, wait, that was, sorry, number 24. Let's see. integral r cubed over square root of 4 plus r squared. Four plus r squared, 4 plus r squared. All right, dr. All right, this one is tricky. So what are you going to choose? So maybe you look at a basic substitution right now. And the question, I guess, becomes, you know, are you going to treat this whole thing as u? Are you going to treat just the top as u? Are you going to treat 1 over the square root as u? Do you see anything that gets better? I mean, I know if I use this to be u, r cubed, then I can differentiate that and get r squared. But then I'd have to integrate everything else. So let me show you what I'm saying. If I do this, then dv will be everything else that's here. So the question becomes, can you integrate this? So can you integrate something like that? And it's not obvious. Now let's see, we'll check our formula sheet, because that does look kind of like something I've seen in a formula. Let's see if that's on your first 20 formulas or not. No, you don't have that on your formulas in the first 20 of them. Now, you have this, well, you know what? On this page here, if you look at formula 25, okay, formula 25, I'll just write it out up here. I'm going to lose my page. Formula 25 says if we have integral du over square root a squared plus u squared, that'll equal to natural log u plus square root a squared plus u squared plus a constant. That's formula 25. And so we have that, we have this right here. Here's the problem. Even though we can go from here to here with that formula, and we can go here down derivative easily, think about what voodoo is going to be. This new integral is going to be this answer right here times 3r squared. That's going to be a mess. It's going to be a disaster, because I'm not going to have any hope, I don't think, of integrating that very easily. So it doesn't appear that that gets any better. So we're kind of at a little bit of a standstill here, which is why this is one of the harder problems. So I'm going to try something a little different. Okay? If this were just an r up here, then this would be basic substitution, because I would have, here's u, the derivative that's right there. But it's r cubed. So watch what I'm going to do. I'm going to rewrite this r cubed as r squared times r. And let me try a basic substitution to start the problem. I'm going to let u, basic substitution, not integration by parts. I'm going to let u be equal to 4 plus r squared. Then the derivative of that, we know, is 2r dr, which I have an r dr here, right? I'm talking about just this. That I can scale both sides, 1/2 du is r dr. But I still have to resolve what is r squared then, because this right here is u. The r dr is going to be taken care of, but the r squared has to be taken care of. So this is where we can go up to this problem here, or that part of the equation, and we can solve for r squared. So r squared is equal to u minus 4, subtracting 4 on both sides. So let me see what happens here. I'm just going to do this basic substitution. This integral is going to become, the r squared is u minus 4. All right, and then over, this right here is square root of u. And then the r dr was 1/2 du, so I go 1/2 du. And now this is a pretty basic integral here. We actually did not even need integration by parts because we can split this up into two integrals. So I can go 1/2 integral, let's see, u over u to the half is u to the half. And then minus 4 over u to the half is 4u to the negative 1/2 du. And that's just power rule on each one, so I take the antiderivative of each one. I'll continue up here. Actually, I'll see if I can squeeze it in right here. So this is equal to 1/2. Now, let's do the antiderivative. There will be a plus c out here. Antiderivative of this, add 1 to that, we get 3/2. 1 over 3/2 in the front becomes 2/3 u to the 3/2. And then here we're going to bring the negative 4 with us, but we add 1 to this, that gives us 1/2. 1 over 1/2 in the front is a 2. So that's going to become a minus 8 u to the 1/2. And now you just need to remember what was u. U is this. So, and I'll distribute this through. So let's see what we get here. Here to here, the 2's cancel, you get 1/3. U was 4 plus r squared to the 3/2. And then here to here is minus 4, then 4 plus r squared to the 1/2, plus a constant. And that's it. There was no integration by parts. I'm sure you can do it with some integration by parts, but this is clearly the easier way because you recognize that little pattern here, that you could peel that r off. Now, just for kicks, I'm going to check this. I'm going to take the derivative. Because I didn't use integration by parts, I'm going to take the derivative of my answer just to check it. And remember that what we should get at the end is this. So let's see. I'm going to take this here, chain rule, right? 3/2 comes out, I'm taking derivative, not antiderivative. 3/2 comes out, hits this, the 3's cancel. I have 1/2, 4 plus r squared. I subtract 1 from this power, so I get 1/2. And then I take times the derivative of what's inside. Derivative of what's inside is 2r. And I'm done with that. And then I'm going to subtract from that the derivative here. So subtract from that. Okay, 1/2 comes out, hits the 4, that becomes a 2. Then it's the 4 plus r squared. And I subtract 1 from that, so that's negative 1/2. And then times the derivative of what's inside, which is 2r. And I'm done with the derivative. Now let me clean it up because I want to show you, we want to verify that it's equal to that. So, wait a minute, 2, yeah. So this 2 and this 1/2 cancel. So this right here is just r square root, so there's r square root 4 plus r squared. Minus here 4r, and then this is a negative, so it's going to be on the bottom. Watch. Let me do it this way. 4r over square root 4 plus r squared. Now right now it doesn't look like we have that up there, but these are two fractions. Here's a fraction, and so I can get a common denominator. So that means I have to introduce on this fraction a square root of 4 plus r squared on the bottom and the top. So when I put it up here and down here, this times 1 will get the common denominator, but when I multiply this times this, the roots, these two roots go together and basically go away. So what you're left with is, let's see, the 4 plus r squared. That's what you get when you multiply this times this. And then you still had an r out there, minus 4r, then over the common denominator. The common denominator was this right here, so square root 4 plus r squared, which equals, now distribute this r through, 4r plus r cubed minus 4r over square root 4 plus r squared. These cancel, and you get r cubed over the square root of 4 plus r squared, which was the original problem. Nice when it works out, right? Okay, so let's see here. I only have about 20 more minutes, see how many more of these I can do. Number 25. Integral natural log of x, the entire quantity squared dx. Now, be careful here because that squared is acting on the entire natural log. It is not acting on the x only. If that squared was on the x only, then we could use the property that allows us to pull that out. But we can't because the squared is on the entire thing. So we cannot do that property. Well, so again, we're kind of like, well, what do we choose for u? I mean, I think the only thing we can choose would be maybe the whole thing. Let's try it, see what happens. And that forces dv to be dx. All right, so the derivative of this, we have to use chain rule. The 2 comes out. We have natural log x, all of that to the first power, which I'm not going to write, times the derivative of what's inside, which is 1 over x. Then dx. Right, derivative of natural log of x, 1 over x. Over here, we integrate, we get x. All right, so let's see what happens. We've got ultraviolet, x, natural log x squared minus integral this times this. So notice that this x and this 1 over x are going to cancel each other out. And all we're going to be left with is 2 natural log x dx. I'm going to pull the 2 out. 2 integral natural log x dx. Hold on, there's someone at this thing. Yes, sir.
Giovanni?
Yes, sir.
Hi,
Oh, are you? So now we need to try and integrate natural log of x, but we don't have a formula for that. So what we're going to do is just repeat the integration by parts. So we'll set up u is equal to natural log x, dv is dx. We'll integrate from here to get x. We'll differentiate here, du is 1 over x dx. And so this integral right here, right, everything I have in here, is going to be a brand new integration by parts. It'll be another ultraviolet minus voodoo, so let's rewrite what we first had from the first integration by parts. And then subtract from that 2, and then now in brackets, integration by parts here. So ultraviolet minus voodoo, integral. Now voodoo, look at this, is going to be nice, okay? Because look, you have x here, 1 over x here. They cancel, all you're left with is dx, or in other words, just 1 dx. And so that all you need to know is the antiderivative of 1. So this is going to be x, natural log x squared minus 2, x natural log x minus antiderivative of 1 is x, plus some constant of integration. And that's our answer. After we clean it up a little bit, we'll be done. So x natural log x squared minus distributing. So we get minus 2x ln x plus 2x plus c. And that's it. So I'll check this one again. It'll take about 2 more minutes. All right. Okay. So I'll integrate this one, or I'll differentiate this one just to check it. So it's going to be a little complicated. We have a product rule here. We have a product rule here. So product rule on this, I'm going to get derivative of x is 1 times this. And then derivative of this times this. So derivative of this, we did that earlier. It was 2 times natural log x times 1 over x, but then times this one times x. Then we have minus. Now we're doing product rule right here. Derivative of 2x is 2 times the natural log x plus, now be careful because that minus was out here, so if we do product rule here, leave the minus out, do the plus inside. Derivative of natural log x is 1 over x times the 2x. Finish the product rule there. Derivative here is pretty straightforward. 2, derivative constant 0. So hopefully, I'm hoping everything over there cancels and all I'm left is with this. So these are gone, which gives me natural log x squared, and then 2 natural logs of x. And then here we've got minus, distributing the negative, minus 2 natural logs of x. And then distribute here to here. These x's cancel. I get minus 2 plus 2. Gone, 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 gone. And this is the integrand. That's what we were hoping for. Okay, that's going to be it. I'll try and do the others some other time. 25. So I need to do 26. So I think there's 1, 2, 3, 4, 5 more to go.